was the problem in the large room? That the presentations are always downloaded from the internet?
They always are, yes. And what happened in the was that
Yeah, please go ahead.
what happened is that the power failure also affected the main router of the university, which is in a building next door.
Right.
And they had to reboot the router.
But why?
Exactly at the same time that we were trying to start Peter Kirsten's presentation.
Yeah, sure. But we could download them locally just before the start, just in case of. Do you know why Bart disappeared and he left everything here? I think that they had some problem with the HCP.
Yes, I wanted to ask you if you use a network or something. I'm not responsible for. I'm not the company.
No, but this.
I don't know from the course, but if there is a problem, you can tell me to phone them.
Yeah, I think that we should. Yeah. Bart, what's the problem? What's the problem? Why you disappeared?
I did not receive an IP address, but I should be in port 2 till 10.
Okay.
So you don't have to. No, please don't. Please don't do that.
I asked your colleague, and I could insert in port 2 to 10.
Okay. Let me debug first from here, and I'll tell you what to do. So, which is your PC?
This one.
This is not. This is ours.
Yes.
That's working.
That's
Yeah,
working.
this is working.
This is a wireless one.
But this is working. That we need to fix that.
I know. Okay. So.
There is a link, but we need to have it in port 2 till 10.
Okay, I'm going to call my colleague.
What lecture is starting yet?
So what's the order?
What lecture is
So
starting yet?
Yeah.
final?
No. Actually, the order is.
Oh, it's fine with me.
Yeah. No, I was thinking to keep Peter Kirsten as the last one. So you would be the second. Is that a problem?
Class wanted to be here for the Imran detective, and he's the head minor in the presentation.
Oh. Okay.
But
So.
it's no.
No. But I mean, I just wanted to follow this order.
Okay. Yeah, that's logical. Indeed, it is logical.
But so which one class? Okay. So yeah, he might be on time. Sorry.
Where is the quality of service lecture?
The quality of service.
Yeah.
It's in Amphitheater 1. That's downstairs.
All right.
Thank you. The big one. But it is logical to do it like that. But I saw on your PC that my
The order on the internet is different, but I was thinking of following this order, which is the same here in the program. So
it would be a bit weird.
And also, Peter Kirsten has more than 20 slides, so I prefer to keep it at the end. So if I have to cut it.
Θα το μεταφέρω εγώ. Πες μου όμως το εξής. Είμαι στο αμφιθέατρο του Ορόφου. Με ακούς? Ωραία. Λοιπόν, είναι ένας εδώ πέρα χρήστης. Θέλει να κατεβάσει να το κάνει plug σε κάποιο πόρτα του Cisco. Του switch που έχουμε εδώ. Σε ποια θα το κάνει? Από τις πόρτες 2 ως 10. Άμα δεν παίζει η πόρτα αυτή, τι γίνεται? Σε ξαναπαίρνω τηλέφωνο? Εντάξει, γιατί εγώ τώρα είμαι εδώ από πάνω. Από τη 2 μέχρι τη 10 λες. Can we try from...
Yes. Once again, which session is here because they're asking me.
This is the recent results one.
Here, reason results one. Okay, reason results one. Okay.
We should fix it now or later.
Take your time.
still need to test this with the beamer, or can I switch
No,
the
you
beamer
can
to
switch
this
back.
one?
Sure.
Υπάρχει περίπτωση, απλώς πρέπει να το δώσω στον Νίκο. Πάρε το χρόνο.
I did not take it out. I think we changed something on the beamer. Can we change back to this presentation over there? Can we change back to this presentation on the beamer?
Put the beamer on this one. Oh, that's the way.
Oh, okay.
He did it for you. Go with Tiffany. It's this one.
Yep, there it is.
One more time so you can have it again. And then
Τάσο, ακόμα δεν μπορούμε να πάρουμε εδώ πέρα δίκτυο. Όχι. Ορίστε. 4 η ώρα τώρα σε λίγο έχουν την διάλεξη. Πρέπει δηλαδή να κατεβάσει αυτός. Εντάξει.
For the moment, can you do it worse? Let's not rush it. Could we try and port
Yeah, we
this
could.
side, maybe?
They told me from 2 to 10.
Maybe try 10. So above 10. Shall I renew?
I mean, now it's okay. Now there is this slideshow running, but you can also use the arrows. If you use the arrow down and arrow up, then you move from one slide to the other.
And also inside the slides for these parts.
Inside the slides, yes, you can use this. You see it like this. Or maybe there is a pointer. But
Oh well, no, I
cannot.
don't. If I need something,
Okay. And if you want to sit, you can use this mic. This is also on.
Okay.
It was on. No, it's not anymore. But if you like to walk during the presentation, you can use this one. I will keep it on, so it's.
Oh yeah, that's better. Yeah.
Welcome. We're going to start this session. Welcome to this session, which is the recent results first. This session has 4 presentations of quite a different nature, but that's typical for this kind of recent results sessions. And since we are starting with a couple of minutes delay, I would suggest to immediately start. I'm going to just need to do some work to download the first presentation. The first presentation is from Felix Kugler from Switch. Felix is working for Switch since well, more than a decade, and he's now working in the networking group, where he's responsible for the deployment of the Switch dark fiber-based network infrastructure. And Felix is going to talk about the bidirectional use of dark fibers in Switzerland. Oh, that's...
Thank you. Good afternoon, everybody. Unlike many other talks you might hear this week, this one is not about fancy things like 40 gigabit per second transmission, switching light paths. My talk is just about improving or optimizing existing technology. It's about single fiber transmission instead of 2. So now you might ask, why make things complex? Now, fibers are cheap today. The problem is, at least where I live, it's not 2. So fibers are there. You can afford them, but they won't be any cheaper. So fiber prices are stable, whereas equipment prices still go down. That's the reason why it makes perfectly sense to make more of your fibers. There are different ways to do this. One is you can increase transmission speed. There are some technical and economical limits, and I'd say right at the moment it's about 10 gigabit per second, which is feasible and economical. You can apply all sorts of multiplexing, time division multiplexing. You can make wavelength multiplex, which is very, very powerful. You can multiply the available bandwidth by tens and more. And there is the possibility to make bidirectional transmission to use only 1 single fiber instead of 2. Of course, you can combine nearly everything together. When Switch started to deploy a dark fiber backbone in the late year 2000, we made a call for tender, and we asked for a wavelength division multiplex system with at least 6 channels of 1 gigabit speed. And we suggested to offer bidirectional systems, but it was not mandatory. Well, this was supposed to be a picture here on the right side. What we got from this tender was a Sorrento Gigamox DWDM system. We deployed the system on 3 long links of about 900 kilometers altogether. It's not the carrier class system, so it's not as expensive, but it's fully okay for everything we need. It offers transparent optical paths on all links. For example, from Geneva to Zurich, which is about 360 kilometers, we do not need any regeneration, only optical amplification sites. The optical paths are designed to support 10 gigabit per second channel speed. We did not deploy 10 gigabit interfaces at start, just for cost reasons, but we started to do so last year. Luckily, this was a bidirectional system, so we only had to use 1 of the fiber pairs we bought. This means also that we only have 16 instead of 32 channels, but that's not a problem. We only use 5 or 6, and I think that's enough for a longer time. The extra hardware which was needed to support bidirectional transmission was in the order of 7% of the total hardware price, not that much. Now, I don't want to go into all details in this picture. Just this is how a DWDM node looks like. If you have many optical wavelengths multiplexed together, you have to separate them for adding or dropping single lambdas. This is done with a cascade of filters. In our system, it's a cascade of 3 filters, and the first one to the left is an interleaver which separates adjacent channels. Then you have 2 signal paths, and in these 2 signal paths, the lambdas are spaced 200 gigahertz, not 100. So it's easier to make passband filters. The next 2 cascades are simple passband filters. Now, the nice thing about this is the first element, the interleaver, is a bidirectional device, so it works in both directions. And with this system, it's very easy to make it bidirectional, and that's what we did, or the company is offering this like this. So you end up with a 16-channel system, and all you have to do is put in your amplifiers. Amplifiers and compensation elements have to be on the path which is separated. So, in the first 2 years of our project Switch Lambda, it's the name of the project to deploy dark fibers in the Swiss NREN, we only used a single fiber on all links. And we did between 3 and 6 channels, and each optical channel had 2 gigabit Ethernets. Then later we started to add smaller sites. Small sites are engineering schools which had at that time 2, maybe 10 megabits of bandwidth. And their access to our network was pretty cheap, so we couldn't afford to put in a lot of equipment. So there was a fiber left. Now we used the second fiber, which was free, and obviously we had to find equipment which was also inexpensive. And that's why we looked into making gigabit Ethernet over a single fiber. Actually, we daisy chained some small sites between DWDM nodes. There are different ways to make bidirectional gigabit Ethernet systems. One which was known since quite some time is to make a mix of 1300 and 1500 nanometer lasers. So in one direction you have 13, in the other 1500 nanometers. This works. You have very low requirements on the laser. It's quite broadband. However, the reach is limited because at 1300 nanometers, fiber attenuation is nearly double compared to 1500 nanometers. And these low-cost solutions are available today, but we had spans from 80 to 100 kilometers, and it was not enough. So the next possibility is a CWDM system. 2 years ago, GBICs for CWDM systems were available. They are in a 20 nanometer grid, and you just put it in your router or switch. And you easily reach up to 100 kilometers. Of course, you need an extra device which was not available on the market. It's an external coupler to go to one fiber. We did this together with a Swiss company who had the knowledge to do this. Nearly the same you can do also with DWDM. You can also buy DWDM GBICs today, DWDM filters. It's a bit more expensive, not that much, but there's not much benefit in it, except if you want to add more channels, many more channels, and if you have to use optical amplifiers. Optical amplifiers have a bandwidth of about 30 nanometers, and that more or less needs DWDM. So The first approach to build an optical coupler box was this one. The idea was we have very good fibers, we use the best available connectors with low reflection, and what we need is a device just separating the two directions. And this was an optical circulator. It's a 3-port device. More or less it works like this. What you put in on port 1 goes out on port 2. What you put in port 2 goes out on port 3. And it has a very high isolation. So basically this works. Except you have reflections. You have reflections from connectors. You have reflections also a little bit backscatter in the fiber. And this adds noise to your received signal. In this example here, that's a pretty bad example, because on this path we had FCPC connectors, which are 90 degrees angled, so they reflect back, and they were old and dirty. So the reflection on the left was higher than the signal we wanted to receive. And on a better link with E2000 connectors over 90 kilometers, we had a signal-to-noise ratio of 7 dB, which was not sufficient for a decent work. So this is what we expected, but we had to try it out. What you can learn is reflection has to be controlled. You have to avoid connectors wherever possible. And if you have to use connectors, use angled connectors like E2000 or APC. Clean them, but it's still not enough. What you need is a suppression of the reflected signals. This is the system we finally deployed. It's now a black box called POC, Passive Optical Coupler. It has a very low attenuation. It's well below 1 dB. And you get a maximum link attenuation of 25 dB, which is more than enough for 100 kilometers. We use two different colors on both sides. We always use 1530 and 1550 nanometers, just because this is in the passband of amplifiers, should we ever use them. This passive optical coupler is wavelength sensitive and is built to suppress reflected signals. This small picture on the right gives you a little bit more details. I don't want to go into all these details. What you have to know is the reflected signal is attenuated by 30 dB, and that's more than enough. And the whole thing is put in a 19-inch 1-unit high box. And it's very convenient, just put it in, and it's not that expensive. This is a picture of the switch network. I don't know whether you know Switzerland. It's about nearly 400 kilometers from left to right, not more. So Geneva, Zurich, a little bit more than 300. And in the first 2 years, we made 3 optical links, 2 to Geneva and 1 to Mano. And this is all DWDM from Sorrento. Yeah, okay. Next 2 years, we went to connect smaller sites. The blue lines are these bidirectional gigabit Ethernet links I talked about before. The green ones are just on 2 fibers, and now the gray ones are the plans we have for next year. The important thing to see here is the gray one in the south. It crosses Italy, and there we need a span of at least 150 kilometers. That's why we started testing. So we took our system and added amplifiers, booster amplifiers on the sending side. There was one problem. So we had spare fibers, unused, but it was not 150, but 190 kilometers, which made the attenuation a bit too high, but nevertheless, the results we got were not too bad. So bit error rate of 10 to the minus 13, and I think with 150 kilometers, no problem. The picture on the right is the amplifier, state-of-the-art, erbium dot fiber, nothing special here. This gives you about 40 dB of attenuation. We did a little bit testing with DWDM, with the same setup, different filters of course. Did not succeed. 2 reasons. DWDM GBX were slightly less sensitive and the filters had higher attenuation. But it's easy to overcome this. Just have to add preamplifiers. As I said, the grey links, 150 kilometers. Once we really have success in getting these fibers, we think we need 10 gigabits. So we need 10 gigabits over 150 kilometers. We plan to test this later this year, in the 3rd quarter. The problem is we need colored plug-in modules, which are not yet available, but promised for August this year. So we will get XenPack modules and optical filters. And of course, for 10 gigabit, you need to compensate dispersion. This can be made with special fibers or solid-state devices, preamplifiers, and we think we should achieve 40 dB of attenuation that we can cover. Now, my last slide, bidirectional transmission, is it for you? It's very easy. Spend a little bit more on hardware, and you save fiber costs every year. Just to show you this gigabit Ethernet solution, 2 GBICs on both sides, 2 boxes, it's 10 kilo euro. It's really not that much. And the nice thing about these boxes, they are passive, you don't have to monitor them, and they are transparent. Transparent means they should work as well for 10 gig. You have 2 options. You can buy a bidirectional system right off the box, which is still quite expensive, or you make one yourself, as I told you before. For us, it was a perfect solution. Of course, we couldn't do it ourselves, so you need somebody who can splice fibers and assemble these things, but all of them are components that are on the market. Now, if you are convinced that single fiber technology is for you, then you realize I can only buy pairs or lease pairs. So what now? So you can make what we did. Well, you say it's an easy upgrade path someday, but you can use one for long-haul transmission and the other one for metro access or for regional links. Or you can do something else. You can swap the second fiber with a good friend. And that's what we probably can do this year. So actually this picture depicts a Zurich-Manno line, which is already operational. And now regional networks pop up in Switzerland, and they could use the second fiber on some parts of their network. They could lease another fiber between 2 spots and give us one of them. So they have a ring and we have a double access to their site. And I think this is really a very, very nice solution, giving redundant networks to everybody. This concludes my speech here. If you have any questions, feel free.
Yes, we have 2 or 3 minutes, so there is time for some questions from the audience. Is there any question for Felix? Yes, one on the back. Can you speak?
What kind of couplers do you use? Circulators or normal splitter 50-50?
No, only the first box was circulator. So this one is more like an add-drop multiplexer.
Okay.
Okay, other questions? One more second. Okay, if there are no other questions, I would like to thank Felix for this presentation. Thank you, Felix. And we move now to the second presentation from Bart Kerver from SurfNet. Bart is working at SurfNet, the Dutch National Research and Education Network, and he's been working in the past in innovation in the innovation department on things like high quality video conference, etc. And he recently moved to the middleware department and is now the leader for the development of the SurfNet detective. And Bart is going to give us a presentation about the SurfNet detective. Maybe I should do something on download the presentation. We start with this.
Yeah. Oh, it's okay.
And you will switch it yourself.
Switch it.
Okay. Okay. The floor is yours.
Okay. After the technical presentation of the previous speaker, now a presentation a bit more focused on end users, actually presenting an application focused towards end users. The next 20 minutes I will be telling a little bit about the project that we call SurfNet Detective. And I had the subtitle Reducing the Amount of Problems with Network Access and Services by the End Users using a tool. And this tool is supposed to be the SurfNet Detective. My presentation is consisting out of 3 parts. The first part will be a little bit in the introduction on how we came to this project. And then I will show the demonstration of the SurfNet Detective in order to visualize what exactly we have built, and later on in the third part I will give a short wrap-up on the presentation and the action points. So how did we come to creating the SurfNet Detective? What we saw, and what most of you will see as research networks or maybe even institutes, is that the everyday usage of the network is shifting towards the usage of advanced and demanding broadband applications. And these broadband applications were initially only focused at a small group of users. But with the growth of the available bandwidth and the power of the end systems, it is now targeted even at simple end users such as myself. One of the examples that I will be talking about later on is high quality video streams. So broadband applications where you require a lot of bandwidth, low latency and little jitter. And the second thing that we saw is that the amount of configurations of systems that actually use these applications are growing in numbers. Whereas in the beginning there were these classrooms within institutes that were controlled in the domain of the institutes themselves. They could configure and they could debug the systems and keep them up to date. But with the coming of laptops and mobile access towards the internet, it is a lot harder to control and to configure all these boxes. And especially if you combine that with the multitude of different network configurations, for example, using a GPRS to connect to the network, or using a wireless LAN as we have around here, or a fixed network, you have a potential huge amount of problems that may lay either in end systems or in the network itself. And the third thing is, what we saw is that there are several institutes who are trying to cope with these problems. There's a lot of institutes or research networks who are providing centralized services, video service again, maybe for use in electronic learning environments. And most of them have same kind of problems. My video is not working, so what is the problem? So we thought, if we are going to look at a solution, let's make sure that it is portable and we can reuse it at other institutes to make it simple and easy for others to reuse our code. So last year, in the end of December, we started a small technology assessment and looked around what is available on the network. And we looked at things like the Web 100 initiative and the Internet 2 detective from Internet 2. But all of these systems lacked some kind of features that we liked. They were either not really focused onto end users, having bad interfaces, or they lacked the ability to log the test results towards a central repository in order to give a tool to help desks to try and figure out remotely what would be possible. Or they were so tightly integrated with all kinds of developments that it was really hard to tailor them for the end users and the institutes to use them. So we thought, okay, in this technology assessment, let's make a SurfNet detectors by ourselves and make it in such a way that we can reuse it. What is the general architecture of this thing? Well, it is not really that difficult. I mean, it's not really rocket science. It consists mainly out of 3 components. We have a NREN portal server, which is in the middle on the top, which is more or less a system that is able to do simple ways of load balancing and seeing what the performance is of the actual servers that do the end-to-end performance measurements. In such way you can build a scalable solution for lots of users. And the third part is of course the clients who you see at the bottom of this picture that can be anywhere hooked onto the internet, either directly or using a firewall or even a net server or on institutes themselves. So this is the variety and all the problems. Most of the clients are not in your control domain, so you cannot manage them. They can be hooked on any way. So how to debug problems with, for example, your streaming video. Good. I think it would be best to show it to you. There it is. So what we did, we created this tool which is the SurfNet detective, and what you're looking at the moment is the interface of the application itself. And on the left hand side you see a set of tests that we have defined: IPv4 connectivity test, IPv6 connectivity test, how it is about with your trace route, is it accurate and is it working as it's supposed to be, am I using a net environment. All these tests can be selected by an end user in order to perform and see by simple click what are the specifics for that end host. Well, I'm not going to run them all, but to give you a demo, for example, if I select SurfNet, this test defines this module determines if you are inside the SurfNet network, and immediately when I click onto this tiny piece of text, we have created links towards a knowledge base that gives end users a very simple and easy to read explanation of what is going to happen during that test. This text was written by some technical guys, and currently we're working with people who are specialized in community support to write real text down to the knowledge of end users. But what I want to say is that it makes it really simple to help end users by providing them simple text about what is going to happen and how the test is going to run. So if I select a test, you also see immediately that the system finds out that other tests are dependent on. For example, if I'm trying to see if I'm in a certain network, I cannot resolve the IP address of this box unless I know if it is a net box or not a net box. And if I'm on the SurfNet network, I at least need to have some kind of connectivity, so you see that the IPv4 connectivity test is automatically selected. Well, let's run the test. Now you see on the right hand side of the screen, the yellow part, that the test is running and it simply starts to execute some underlying applications. In the first case, the test already completed, by the way, was trying to use ping and ping towards a certain destination host. And it reports back in a very simple way, was the test successful or was it not successful? And it gives some details on the result. Well, there's no packet loss, so good work here on the network. And you see some specifics on the tests that have been run. The round trip time is minimum 70 milliseconds and max 80 milliseconds. And you also see that this box is not on a net network and that this box is outside of the SurfNet network we are currently, of course, hosted. If I would have liked to have more information about this test again, I could reselect this knowledge base, and it will provide me with an additional URL that says that, well, okay, the test was successful, but if you want to have more additional information on what you can do, but maybe even more important, if the test fails, what potential reasons can there be why this test failed? And how can I try to solve it myself before I have to call the help desk? Okay, this was a short demo. I can start up some additional tests. Later on you can just download it yourself and experiment with it and see what features are available on the hosted network here. This picture was for the viewers at home. So there's interfaces where you can select the tests on the left upper hand, and you can also set some options, like you can select the language and you can give details on the reports that are sent back towards the server, where you have no details at all. I send some details but I want to stay anonymous. Or you can say, I want to send full details, but they need to have my name so they can help me to trace down the session. Okay, for the wrap-up. The ServNet Detective, as I said before, is focusing on end users on one hand and system administrators on the other hand. So we positioned it as an end-user targeted network information gathering tool. And what it does, as you have seen, is it is a simple GUI targeted at non-technical users that basically wraps around all kinds of applications. And they can be, by a scriptable way, be hooked into the application. The setup is completely multilingual. You can create your own language files, so you have Spanish or Italian support. There's an option to link towards knowledge bases for self-support, where you, again, can try to help end users. And you can have secured updates of new features, new tests that become available using a signed version of download, so that we secure that no bogus software is downloaded. Again, you can log into the central repository for remote help and debugging, and not unimportant, it is cross-platform available, so this is what was lacking on some of the other tools as well. On the other hand, you don't just run these applications to only help end users and let them struggle by themselves. What you want to have is also a tool that is aimed at network operators or maybe even help desk targeted people, so that they can try and help to debug the problems that there are. And again, what we have made is a cross-platform server on open source environment. And the whole thing is configured using a web-based interface. And what this interface does, it makes the specific settings for your network. So, for example, if you were trying to test for multicast IPv4 for a ServNet video portal that we are running, you want to say, I need to have IPv4, and I want to have a low latency link, and I don't need to have any packet loss. And by the way, I need to access a multicast group, which is, and then you define your multicast group and your port. So it is really, it can be stuck into your own network setup. If you then just click, it generates a server configuration, and a client that is belonging to this server, so that hooks up to that server and tries the tests that are available. Now, as I said before, the servers are tailored per institute, and we have a logging towards a database. If you're really interested, I can show later on maybe some details that are logged into the database, where all the details of these different sessions are available, and that can be of help. For example, if, again, the ServNet video portal, you are running on a netbox, and this end user is forgetting about this, you can help in a very simple way. And the most powerful tool for that is the last line, the extended test. This is a scriptable way that we developed to chain all these different modules that we developed with simple if-then-else statements. And here's an example of this script that is available in the Internet Detective. And the first line is is the name of the module that would be on the left side displayed, so the ServNet video portal. And the second line is the simple description that was just below it, describing what the test will do. And then under that you see a link towards a URL where additional information that appeared on the right-hand side of the screen is presented, and where you can find additional URLs towards the knowledge base for the case the tests are successful, or for the case that the tests are not successful. And after that, we start hooking up these different tests As you can see, I did the IPv4 connectivity test, well, for SurfNet video portal. If the test would fail, it would report the end user, SurfNet video portal requires IPv4, and so on. For the IPv4 connectivity test, if the packet loss is too high, more than 0.8%, it would report you have too much packet loss, and you could visit the knowledge base where you could see what kind of problems might be causing these packet loss. So on for the jitter, and so on and so on. So you can chain and build your own test script that uses the variables that are available. And the last item that I noticed in the beginning was that we need to be able to distribute it to other NRANs, to other institutes that can set up their own detective in their environment. It is really simple to adapt the configuration for your local network environment, set up your own set of services, and distribute it towards the end user that you have. You can set up these extended test scripts, basically in a simple format, adapt the descriptions, hook up to your own web-based knowledge system, add languages, and most important for a lot of institutes, at least in the Netherlands, change the branding, change the look and feel so it suits all kind of tools that are available within your own institute. I think that is about the presentation. If you want to look at it, there is this website online that gives further details. You can download the beta and start experimenting with it. Currently there's only a Windows version available, as I said. This is work that we started halfway of March. It is now the start of June, so it is really a beta environment. But it is working pretty well, and you can neatly try to see what kind of nice services we have here at the TERENA Network Conference.
Very well. Now, some time for questions. Yeah, one first here on the first row.
What TCP or UDP protocol port does your test use? Because we use the Internet 2 detective, and this is not very firewall friendly because you have to open more or less all UDP ports. How do you handle this?
Okay. How to handle the UDP tests within the SurfNet video portal? SurfNet detective, that's the question. What we did is we have set up a set of ports that you want to test for. For example, again, for the video streaming, it is necessary to be able to receive traffic on port 554, the RTSP port. So what we do, we have a list of ports that can be opened. We start up a daemon and try to send traffic from outside towards that specific port. If the packets can be reached by the end host, we assume that it would be possible to send video traffic through. There is some specifics, for example, if you have specific firewalls that can open based on, for example, RTSP communications and setup, these kinds of things, but these are the initial tests that we do. Start up a daemon locally and try to connect from the outside inside. What we also do is we try to connect from over TCP for the same purposes, so you can see if there's any Trojans or maybe even daemons running on your local system. And we do it the other way around as well. We can start daemons on the server and try to connect there to see if there's any firewall or any script or any personal firewall on the system itself that is blocking the traffic. And of course there's certain limitations, but these are the initial things that we're working on.
Second question from Dan.
Yes, hi. My question is somewhat related. I love this. And I think we're going to use it. It's great. But you said something about RTSP and firewall inspection and that it might not emulate the real thing. And this is one of my concerns. And I would like to ask if you're going to do something about that. Do you have any plans for putting in real RTSP, real H323, real SIP communication between the client and the server?
Yeah, the short answer is there is a development plan online that describes what we will be building for version 3. One of the assets that we looked at is there a tool available that can do these kinds of performance measurements? For example, this is why we use iPerf, because we don't have the idea that we're going to build iPerf within a few months and do the same, get the same result. But these rather simple protocols most of them are even ASCII based, are simple to implement and build some kind of client-server communication. And we are actually looking into the RTSP communication to set up these sessions, and we can look at SIP as well. That is not in the code that we use. It is really simple to use these kinds of scriptable communication. So we're definitely going to look at that. In this version it is not, but it's going to be in later on. And if there, for example, for the next version, we also have requirements for voice over IP and testing if your network is capable for voice over IP. Well, then one-way packet delay is getting more and more important to know how much is the delay from one end to the other end. And we will be looking at applications that are already available on the network and which one is the most suitable just to wrap around our GUI and make an interface towards the end user. And if it is not available, we will have to create it ourselves. And we can use any kind of help creating it.
Last very short question, if possible.
This, of course, is inside the SurfNet network. Do you have a vision of how across network, tests across network? If I'm calling from one network into SurfNet and trying to find problems, do you have a vision for that solution?
At the moment, we are using the NRAN servers that are located in Utrecht, and it would have been better to have here locally in TERENA a detective server up and running. And I've been talking with Bob Riddle from Internet 2 a little bit, who developed the initial IDs on the Internet 2 detective. And what we were talking about, in the architectural picture that I showed, there's this portal server, and this portal server can direct you towards a specific server somewhere closest to you or based on some other kind of specifications. And this needs to be developed, and we do not have a clear picture on how to do it, but it's certainly interesting to have a web page. You just go to and say, measure my closest or my local network, and it will present you the configuration for the local detective server. Sure, that is of our interest.
Well, sorry to cut. Well, I would like to thank Bart for this interesting presentation. And we move now to the third paper. This is a presentation about a paper about distributed meta-information searching. It's David Barreiro, who's announced as a speaker, is one of the authors, but the presentation is going to be given by Diego Lopez. He's responsible for the middleware and the application areas of Rediris, the Spanish National Research and Education Network. I hear it echo. Maybe I'm too close to the microphone. But
it's here. Okay.
And then you have to click on download slides.
One moment, because anyhow it's in PDF, not PPT, I guess.
Yeah, so we have to wait a few seconds.
A little bit more, yes.
Yeah.
Oh, skip.
Okay, the floor is to you,
Okay.
Diego.
I hope. Well, the only problem is that control. Oh, okay. It works. Yes. Cool. Okay, it was originally made in OpenOffice, you know, and it's a matter of being an interest with this. Well, first of all, let me apologize because David was not able to come. He's the one who has really made the actual real work inside the Searchy, which is what they're going to present you as part of its PhD works. I am directing him together with Oscar, which is here. So. The idea of this system comes from that so to say so heterogeneous and incompatible source of information that in any organization and even worse, when you are going to a big organization like something like NREN, or even a university with its different departments and sections, etc. You have information kept in very different formats. We have different ways of accessing them, incompatible ways of searching, of accessing, of reading, of storing or not storing, as it is in the most cases, metadata. So whenever users has to locate some information, some corporate or again joint information, things are become really complicated. You have to integrate things. You have to develop custom or a very expensive middleware oriented to exactly the formats you are using. And at the end, it's always difficult to locate information. And well, you have to rely somehow in the ability of people in finding the information somehow. So when we analyze this, we decide to try to build a system that would help users in locating information in this kind of heterogeneous environment. Our idea was to build an abstraction layer who could act as a mechanism for service federation. The idea is that each service would continue operating independently from each other, offering whatever interface the services were willing to offer. For example, we were not trying to, so to say, to make all the, for example, all the web search interfaces in all the Spanish universities. For example, to use the same software to make them compatible, or we were not trying to mandate a single database manager or whatever in any case. So our idea was to be able to federate different services offering different formats of information. And this is on the so to say in the more functional part, and in the data integration part. Our idea was to provide an extra model of information based on a semantic representation of data. Features in this kind of system, you can say, well, of course, scalability. You need to scale this from a campus. From a campus setup to a national network setup or even beyond. It should be extensible in the sense that it should be able to easily incorporate new sources of data. And something that sometimes is a little bit forgotten about, we forget about system administrators and we forget about ourselves. In the sense that we would not like to have a very complicated thing to be run. Just think that you are running thing like an Oracle server, and you are running some information there inside the Oracle server, and somebody comes to you and is asking just to build a Tomcat application server, a bunch of Java classes inside of it, a bunch of configuration files to be figured about. Just to integrate your database in a project or federation of search services. That's something that has precluded very much, I think, some other efforts. So one of our intention was to make things very, very, very simple to configure. So, well, of course, we wanted to make this compatible with what is happening now in the web. And our idea was not to provide also any means of accessing the information. The idea is just to have a service for locating it. Well, sorry. Yes. So in the we face a couple of as I told you at the beginning, the need for federate very heterogeneous sources of data. That means that we have to work in a very heterogeneous environment using a technology able to overcome any hurdles that we could find in our way, including from firewalls to different configuration, different architecture, whatever. So we decided to go for web services running on top of SOAP. We wanted to make an information integration. We wanted to have a semantic data model, and the idea was to move to the semantic web technologies, where we decided to use RDF inside the SOAP, RDF with a Dublin call limited vocabulary. Design decision regarding the objectives I have shown you in the previous slide was scalability. Scalability means that you need, for sure, a distributed architecture. Further on, I'll show you how it works, the fully distributed characteristics of Searchy. Extensibility, it's design. The design of the Searchy part are very, very, very modular, so they are, it's quite easy to extend a given agent. And simplicity in configuration, what we decided is to build an autonomous application that could be installed everywhere. It's simple to put it in few words. It's a jar file that is installed, it opens a port, and it waits for SOAP requests coming from the authorized sites. Just this, it's very simple to configure using XML as a single XML file, and the only thing that is a little bit tricky is to make the mapping between the local data representation and the RDF. So, all this is the Searchy, as I told you at the beginning, is the brand name of the system. Well, if you can look at it as different from different points of view, you can think that it's a search engine that is distributed and that use metadata instead of raw data. That's maybe that's the less interesting part, because there are many search engines on the market right now. The important thing is it's a gateway able to perform semantic translations of the information stored in different data sources, offering a coherent semantic view of the data. In general, it acts as a middle tier of a general location architecture that enables the users of it to locate information in a flexible and federated way. It's built as a network of cooperating agents in which each one is communicating with the other using a standard procedures based on SOAP and LDF. And well, to make it as extensible as we can, we have designed the agents as you say there. There is a core, which is try to be the blue part in the figure, which implements the SOAP engine and all the stuff relating with the RDF mappings, up to the final mapping onto the data sources, which are provided by the providers that are the ones that manage how RDF requests and RDF responses are mapped onto a direct request to the data sources and back from the language we are using. And of course, the agents need a backend, which is what we call the data sources. Well, this is an example configuration of how Searchy could work. Right now, you can think that there is a user using whatever user interface, and we have developed several. The user interface, by configuration, is able to connect just to one agent that is acting as, if you think of it as an aggregator of some other agents that can be connected to different data sources. So, in that sense, the search architecture is sort of recursive. It can self-reference. There are agents that can use other agents as that data sources. So the user interface communicates with the so to say main agent, and this main agent, using the SOAP search interface, is able to connect to different other agents that are distributed over the network, and who are they are, as you can see in the bottom part of the figure, they are connecting to some other agents and providing different current views to different families of users, or are directly connected to actual data sources, like, for example, the Google API, or the databases using SQL or LDAP server. So we have decided to set a current semantic field to use only the Dublin core term set in order to make the searches between the agents.
5 minutes.
Well, in the latest version, there are 3 types of providers that are available that we think that cover wide range of currently available services, like whatever SQL database, LDAP servers, and we have also make some experiments with the Google API using web services. We think that it's quite easy to develop new ones, and that there is a couple of guys now working on developing new providers. Well, in fact, we think that there is the searchy software as it is now can be seen also as a container for the information providers. And up to now, something that is quite important, and you remember the previous figure, is that the user interface is separated for what search is. And to demonstrate that you can have different user interface, we don't want to have just the typical web search engine. We have made different proof of concept interfaces that are now running. There are clients running on a servlet, Java server pages, and there is another direct application made in Python. And we have also developed Java and Python classes in order to integrate searching capabilities inside any other application. Well, just to conclude, I think it's okay. Well, we have made, we have deployed the searching in the Redis environment and connected it with the 4 different sources of data also in the University of Alcalá. We think that the concept has been proven, and it quite well integrates the data sources, and we have a long list of open issues for future development, and his work is ongoing on this. We want to integrate full support for RDF and all to being able to integrate ontologies inside the search engine, be also using the ontology sources also as agents, so we can make a very flexible system for locating information. We would like to integrate it in grid architectures in the sense of locating resources also in grid. It's something that we have been thinking about making the search OGSA aware and help user in locating resources. We would like to support complex queries supporting full RDQL, which is the query language that has been defined for RDF. We will definitely include support for access control based on SAML because, well, I'm working on that, so it's something that we will be available in the near future. And we're working also in the implementation of new providers. As I told you, we are using Harvest as a collector of information from different files stored in local disk. We would like to try with HTTP, FTP indexes, etc. We're trying and we are beginning to play with UDDI and semantic web services in order to make the system more intelligent and more responsive to user needs. Well, right now it's in beta status. It's distributed on the GPL license, and here you are some references we have put in the source file right now. And well, there's a couple. 3 reference more about searching and the technologies which is based upon. That's all.
Okay, thank you. So now we might have a couple of minutes if somebody wants to ask questions to Diego. I don't see any questions. Maybe I can ask you just very quickly. I mean, you have quite an ambitious plan, I mean, about further developments. Are you seeking for collaborations in this respect or not?
Of course, yes. This is part of the reason of coming here to talk about this. Right now there is one person which is a bit full-time dedicated to this. There is a couple of other students who are beginning to have a look on the system. But of course, whoever is willing to collaborate will be very, very much welcome.
Okay. If there are no other questions, I would like to thank Diego for his presentation. And then move to our last talk. Our last speaker has been very well introduced by Jane Butler just a couple of hours ago. So Peter Kirsten is going to give us a presentation about moving grid systems to IPv6. And I can...
While we're waiting, in IPv6 grid, but what we're talking about here is really lots of people concerned. Most of the work has been done by Sheng Jiang, a research student, and Piers O'Hanlon, both of whom working on the 6net project. Many of the studies as to why you ever want to use IPv6 and grids was done by Brian Carpenter and Ian Foster and Jim Bound, and various other people in the Global Grid Forum working groups. So we're talking about why grids and IPv6, what's the grid, benefits, work on it, and standardization. I'm told I must go rather fast on some of these slides since my chairman has expressed concern about the number of slides which I've already heard indirectly. Grid computing is a fairly fundamental shift in computing, and so is IPv6. It's a major step. So somehow or other, the two must have some sort of synergy, and we'd like to see, in both cases, the common goal of reaching a very large number of internet nodes. And the grid is a collaboration and resource-sharing infrastructure with origin in science. It's a distributed service integration and management technology. It's a very disruptive technology. Lots of things might happen with it. It could be considered an open source technology in community. It's supposed to look like a power grid. It's undoubtedly a marketing slogan, but it's actually a little of the combination of the above. And it's not actually up to me particularly to justify the hype on the subject, although we have been trying to think of, is there any way you can justify why you'd want IPv6 and the grid? Well, it isn't quite like a power grid. You can import electricity. Here you've got to export data. Computing isn't quite a single thing like electricity. It's got lots of different components: computers, data, sensors, services. But if you could do it properly, the sum of would be greater than the parts to construct something new with virtualization, distributed service management, etc. I have some doubts because I know how difficult it is to get even small amounts of things working across organizations. So to think it will be done seamlessly by everybody everywhere, I think is a little optimistic at the moment. This is the sort of project going on at the moment in, for instance, the data grid. Lots of quite complex, worldwide organizations talking to each other. Well, if this sort of project works at all, it's going to have to work in the future, and I'm moderately optimistic that we will go slowly towards IPv6. So some of these grid things must. Well, like public utilities, they've got to be shared, reliable, etc. And one question about them is you might want to assign resources, users, applications to virtual organizations, because grids are supposedly going to be used heavily in industry. If that's the case, virtual organizations are important. So you might have a lot of physical organizations with different virtual organizations on top, sometimes overlapping, sometimes direct. And one thing that will happen with overlapping virtual organizations, that you may want to have a number of different addressing systems which encompass them. That needs some sort of uniform address space to avoid proxies and allow end-to-end security. It's the way in which the IPv6 address is assigned, with the bottom 64 being fairly unique and the upper 64 being having a certain amount of flexibility, would allow a lot of renumbering across it. You would have security boundaries which transcend organizational boundaries, if you can get that past the security authorities in the different organizations, which is a very big if. Undoubtedly, that sort of thing is not achievable at any massive scale with IPv4, and it's one of the few arguments I've actually heard why IPv6 might have a strong advantage in grid activities if grid lives up to all the things it's supposed to do. You could have things like a temporary merger. You can't have private addresses in these four. You don't want to renumber all addresses if you're having such a merger. But on the other hand, you could do it with IPv6 in a way which would be much more difficult with IPv4. And if you look at the standards, well, you had custom solutions in the early days. The original Globus activities, which is inclined to be the thing you measure where you've got to on grid standards, started about 1905. The GT2 sort of was around 2000. There's a lot of overlap here. GT3 and the Open Grid Services, roughly from 2000 to 2005. And then managed shared virtual systems, somewhere between 2005 and 2010. And we're somewhere in the middle of all this. And as part of this, you need to have a service-oriented architecture. You've just got to be able to have all the different parts working with IPv6, both as far as the standards and as far as the implementations. Well, one thing which has started very recently, only started 4 months ago, is actually to have an IPv6 activity in the Global Grid Forum, which is where this is assigned. This is the sort of way in which the Open Grid Services architecture looks like. And the standardization comes both at the resource framework and the upwards middleware. I've talked a little bit already about the benefits of IPv6 to the grid. There are a number of possible advantages. Actually, I'm not going to push these. But it's convinced the Grid Forum enough to set up a working group that's co-chaired by Brian Carpenter and Piers O'Hanlon, Brian from IBM and Piers from UCL. And it's at the moment looking at 3 drafts. What are the version dependencies in the global grid forum specification? Do something about preparing a guideline for IP independence in the global grid forum specifications. And since one of the things used a lot is status, is this Java, what's the status of Java API in the context of IPv6? And these guidelines are pretty far along. One's looked at 88 documents, and 24 had some form of dependencies. Quite a few failed. The rest had other dependencies. So that's already a very useful document in how one should in the future be writing the GGF specifications. And also, what's the status of the Java Kit API is very important as well. Now, Globus, if you read anything at all about the Globus specifications, particularly from around about GT3, you will find a lot in it that the core is now fully IPv6 capable. And the fact that Java is now IPv6 capable means that, in theory, all of the Java release, with one little exception, would be now fully IPv6 capable. The only slight problem there is that Argonne, who are developing the Globus toolkit, has no IPv6 inside Argonne National Labs at the moment. So while they've tried their hardest, they actually had no way of testing this. And what we've been doing for the last year or so has been mainly to identify places where this didn't quite work. And I would regard us being completely successful if when GT3.x comes out and we have no work to do with trying it with IPv6, then things will work. GT4 is doing something with the new framework, web framework, and there I'm sure problems will start again, although slowly Argonne is actually putting in IPv6, so they haven't yet. In the 6net project, what we're trying to look at is actually now not going just with eyeballing, but actually making certain specific implementations of Globus work in the IPv6 framework and trying them with real applications. So what we're doing is we're porting and testing Globus to IPv6, looking at what things don't work, feeding code back and collaborating with the Globus tool team. And we're also doing something very, very similar with Access Grid, but I won't say, I can answer a bit in questions, but I won't say much about the Access Grid stuff for sheer shortage of time. But in fact, a good part of Access Grid is the Vic and Rat voice and video tools, which are already done under 6net and earlier things and came from UCL in any case, but there is a lot more to it. We're trying to deploy it on the 6net text beds. We're looking very seriously into transition, because if we're lucky, we can persuade some of the grid people to let us work with IPv6 implementations which interwork with theirs. To expect the whole of the grid community to move over to IPv6 in the near future is very unlikely. And we also want to look at some of the other advantages of IPv6, for instance, the better support for mobility, and then to promote the IPv6 compliance. At the moment, very few protocols still need to be modified for IPv6, but Grid FTP is one of them. And in fact, we have helped bring about this situation. There's actually going to be a long transition period, and so you're going to want to have some form of transition mechanisms between clients and services. The first thing is to make an IPv6 client able to access a dual stack server and an IPv4 client access a dual stack server, but that's only the first part. The next part is you'd like to have IPv6 grid nodes, IPv4 only grid nodes, servers accessing both of them and some form of gateways in between. Then you start looking in like this. And a lot of this works, a lot more is still being tested. For instance, we have no problem at all on our present systems with an IPv4 only client and an IPv4 only server. We have no problem with an IPv6 only client or an IPv4 only client acting a dual stack server. We have no problem the other way around. We have no problem in a dual stack client accessing a dual stack server. We have no problem in the pure IPv6. We're in the process of seeing where we might have some problems with an IPv6 only client going to an IPv4 only server, or an IPv4 only client going to an IPv6 only server. The straightforward parts of that are no problem. The question is how well these survive in the case of both mobility and security, and it takes a little bit of time to work through because some of the models that Globus has for these is a little strange. Well, the first thing is to make them work in that context. The interesting part comes when you now take some real applications. And here's one called eProtein from UCL. There's another about weather stations and sensors in Southampton. And our aim is to have working in September these complex, real grid applications working in heterogeneous IPv6, IPv4 environments accessed from mobile IPv4, IPv6, also IPv6 clients. It's work in progress as distinct from results. It's an essential prerequisite for getting the grid community to take IPv6 more seriously. There are lots and lots of other projects which we are concerned with one way or another, and it's important to us both that various of these projects are either grid, EGEE we'll hear about tomorrow morning, which intends in year 2 to look to see whether it could use IPv6. Year 2 is next year. That means that we have a letter from them that they are enthusiastic to see what results we have. It'll make their life easier if they decide to go that way. We're looking at various ways in which security can be provided on a large scale in an integrated project, in CNIT. There are others working, there's a Japanese project, and Moon VP6, of course, is a large US IPv6 project. Again, all of them are looking at these things. It's important that the SunGrid engine and other sorts of grid clusters are moving towards IPv6 capability, and if you want to read more about it, plenty more of references to this sort of activity. Thank you.
Okay, thank you, Peter. You actually made it in a perfect timing, I would say. We have some 5 minutes for questions. Are there any questions to Peter? Maybe we have to wait a few seconds just for people to think. Well, if there are no questions, I would like to thank Peter for the presentation, and just invite people to talk to the speakers offline if they have if more questions come out. Thank you very much.
Thank you.